As I already opened and named the project name, and the project name is q.q. So first thing first, go to the sys, and you can see that the timeless source is timer 2. And then go to the RCC. As you can see that the high speed clock source is the crystal ceramic resonator. And if you go to the NVIC, I have enabled the user to global interrupt. And go to the connectivity. As you can see, I have selected the user 2, and the mode is in the asynchronous. Now, now go to the main. Now generate the code and go to the main.c file. Source main.c. I have already written the code for you, so that's to make the video short. So the moment I generate the code, the cube ID will automatically include the necessary libraries. Besides, I also have to add some additional libraries by myself, like the stdio.h and the string.h, etc. Cube ID also care about the handler and the HAL function initialization by itself. And remove the CMSIS header file. Now I have to create three task handler. So in private user code, define the task handler. I am defining three task handler, two task handler for the sender task and one handler for the receiver task. Now I will just create or define a queue handler, and the name of the queue handler will be a simple queue. Now I have to declare three task functions, and they are also at the end of the code. I have written the three task functions. So first one is the sender. HPT means higher priority task. As I already written the task function at the end of the code, so the moment I click on this, it is showing me the whole function, which is just written at the end of the code. So third one is the receiver task. Now I have declared a variable which is rs data. Now go to the main code. So inside the main function, we have to create the queue. As you can see, it's a simple queue, the queue handler, and I'm using sqcreate to create the queue, and the size of the queue is 5 times of the size of the integer. So if simple queue, which is the queue handler, returns 0, then we need to realize that the simple queue has not created. Then I will declare a character type string, and I will write unable to create the string. So using HAL UART transmit function, I will send this string through UART, so I can read them from my PC. Otherwise, I will write string created successfully, and I will send it through UART in order to see them from the PC. Our next step will be to create three tasks. So using stask create, we'll take some parameters. So first parameter is the task function. Say center higher priority task, center low priority task. Another one, the second parameter is the name of the just function or anything. And then I have to pass the stack depth. Then I have to pass the parameter to the function of the task function. So here I'm not sending any kind of parameters. So I rather write null. And the priority for the first task function, I'm assigning the priority of 3. And the next and the last parameter is the task handler. So I have done the same for the rest of them, but in that case, I am passing 111 as a parameter for the center low priority task function. Now I create how you receive interrupt. What does that do? It will create an interrupt and to receive something, and if it receives something through UART, then it will store it in the RS data variable, and delay will be 1. Now I will start the scheduler. Now we have come to the final part. As I already told you that I have written the priority, the task function at the end of the code, and the first one is the sender high priority task, and it's really high priority because I have assigned the priority of 3 for that task. So it doesn't have, I didn't send any kind of parameter to this, so it doesn't have any parameter. So I have written a variable which is integer I22, and there is a delay. So while 1, so I will write the interrupt sender queue to send a number into the queue. So the moment the code or my program enters this function, it will transmit a message which is inside standard queue to send a number into the queue using UART transmission function. And as you can see, so using SQ send function, we will pass queue handler and the pointer to the variable that we want to send to the queue and a delay, and it will, if everything goes well, then um, it will give me a PD pass, and if does that happen, then I will write successfully send the number to the queue successfully, show you what to my PC. So I can read that, and then I can assure that that yeah, everything is working fine. So I have done the same thing with the send a low priority task function, but in that case, I have already passed a parameter which is triple one. So so I have while one to send integer n, which is the triple one, by the way, because I have passed the parameter which is triple one. So it will be sent to the to send variable. Then whenever the program enters this task, it will write insert center queue to send a number into the queue which is low priority. So using HAL UART transmit function, it will send me this data or this string. And as you know, I have assigned the priority which is 2, so it will be a low priority comparing to the first high priority task function. So if sqsend, using the sqsend function, we just take the queue handler and to send pointer, which is a variable pointer, which I'm going to pass to the queue, and a delay function, it will give me a PD pass. And then we can understand that we have successfully sent a number to the queue. So it will send me the message using HAL UART transmit function, and then if we just delay function to create a delay. So I have done the same thing with the receiver task, and it is the low priority task compared to the other two tasks, because I have assigned the low priority number to it. So integer received, it is a variable, and then a delay function. So string 100, I have created a string. So using string copy, I have you know what does a string copy do? It takes the whole string and it will copy to the string variable. Using HAL UART transmit function, I will send this string to my PC in order to read that, and everything is same in that case. It will just using SQ receive instead of SQ send. Um, it will receive the all the sent data that has been sent to the queue, and if does everything all if it is it sends it returns not PD true, then I will write that error in receiving data. Otherwise, I will write successfully received data from the queue, and it will also show the received data using percentage %d and received, which is the variable here. That's it. Just take it. Everything. So using a USB to TTL bridge, I can hook it up with my microcontroller and PC, and I can see all the messages coming through the UART communication protocol, and I can see them from my PC. But instead of doing that, I'm using a logic analyzer, which is Sale I logic analyzer. But in my case, it is a Chinese chip version, but it does work well for me. And I will hook it up with my microcontroller, and using the Sale I logic analyzer software, it will start to show it on your PC, and you can see that every single 2 seconds I'm detecting a signal. And if you zoom it, you can see that the messages that is coming from my microcontroller, and you can read it also from there.